So, welcome for our first topic, switching theory. So, take a look at these images. As you can see here, we are presented we live in we are presented with devices or objects. And as we can see, we live in an analog world. There are infinite amount of colors to paint an object, even if the differences is indiscernible to our eyes. There are an infinite number of tones that we can hear, and there are infinite number of smells that we can smell. The common theme among all of these analog signal is their infinite possibilities, while digital signals and objects deals in the realm of discrete or finite, meaning pag may tag finite, it has only limited set of values that they can be. That could just two total possible values like 255, 4, 294, 967, 9296, or anything as long as it is not infinity. Kaya finite man siya. Now, working with electronics means dealing with both analog and digital signals, both input and output. Our electronics projects have to interact with the real analog world in some way, but most of our microprocessors, computers, and logic units are purely digital components. These two types of signals are like different electronic languages. Some electronics components are bilingual, and others can only understand and speak one of the two. So, as you can see here, analog is continuous or infinite, digital is discrete or finite. Yeah, we have here a lot of uh, infinite numbers. So pwede dito, no? Dito as equivalent value. Dito, mayroon din equivalent value. Ito, as you zoom in, no? As you zoom into this portion, you will still see a lot of values in it. Okay? So, digital signal, as per shown in the figure, must have finite set of possible values. So the number of values in the set can be anywhere between 2 or a very large number that is not infinity. Most digital signals will be of one of two values, like either 0 volts or 5 volts. Timing graphs of these signals are look like square waves, as you can see here. So 5 and 0. Or digital signal might be also a discrete representation of a analog waveform. Viewed from afar, ang kaning wave function nato karon murag tanaw nimo smooth kayo siya nga analog. But when you look closely, there are tiny discrete steps as a signal tries to approximate values. Okay? That mo na siya ang dako nga difference between analog and digital waves. Ang analog waves are very smooth and continuous, while digital waves are stepping, square, and discrete. Dili tanan nga audio and video signals are analog. Natay mga standard nga mga signals like HDMI for video and audio, and naputay MIDI, I2S, and AC97 for audio that are digitally transmitted. So kasagaran sa mga communication between integrated circuits is digital. In mga interfaces like serial, I2C, and SPI are transmitted via coded sequence of square waves. Therefore, sa analog electronics, most of the components that belongs to this category are resistors, capacitors, inductors, diodes, transistors, and operational amplifiers. Ang analog circuits lang, difficult siya kaayo i-design kaysa katong i-design nimo ang mga components digitally. And also, isa pud sa challenge under analog electronics is that this is very susceptible to noise. Even kanang gagmay kaayo og undesirable variation sa voltage ma-detect niya. So lagmit dili na kaayo bag ang analog nga electronics kay inani man nino makita nato ang different components. For example, kani kabalo gitani nga capacitor ni, kani kabalo gita nga resistor ni, kani kabalo ta nga operational amplifiers na siya. So we have also diodes here. So more likely 100% of these circuits has analog components. Let us define na pod kining digital electronics. So ang mga circuits na under aning category gagamit og this digital or discrete signals, or I always repeat that discrete signals are infinite values, are finite values I mean. And ginagamit ang kasagaran ginagamit ning digital is binary scheme, meaning binary scheme duha ra ka value. Katubit tong gisgutan kaganiya nga 0 volts or 5 volts. Napagani ng uban ginatawag nila ang kaning 0 volts is gitawag nila nga logic 0, and kaning 5 volts na to is gitawag nga logic 1. Okay? Ang digital circuits easier just to design compared to our analog, but ang apan lang is more expensive siya kaysa sa analog circuit. So kani siya nga circuit is a very good example of our digital electronics. Later ma-familiar ta kaning ginatawag na to nga JK flip-flop. Okay? Nato mga JK flip-flop, napud tay mga ginatawag nga mga decoder. Kani kay 7 segment. And then napud tay mga I'm not familiar with this, but later we will going to discuss this further. I think this is a multiplexer. Yan. And then syempre na tay digital signal. Okay? So, unsa may advantage? Kabalo kita nga advantageous gid kaayo ang digital circuits. The reason why we are focusing ourselves with this subject kay ang logic circuits is under siya sa digital circuits. Syempre isa diri ang ease of programmability. Naa kay mga gagmay usbon, dili na kayo siya mag-cause dako nga changes sa tibok nga circuitry. Dali flexible siya, dali ka maka-experiment from one prototype to another prototype, or from one case to another case. Syempre, reduction of the cost of hardware because you will be programming na lang mostly of the software. And then high speed, high reliability, design is easy, and result can be reproduced easily. Yan, especially for mass production ng mga